Today, I'm glad to present you our machine learning pipeline, which we implement in mineral filterizer industry. So basically, how we develop and deploy an optical solution to the real industrial process. So let's start. First of all, we small startup from Kazan City, and basically work with mineral filterizer industry, but also with other mining industry as well. So we have a big history with such industry, like 10 years of working directly in workshops with technical guys, try to build a smart solution inside and implement different method of quality control. So here you can see our today's shoulder, and let's begin. So first of all, what our problem? Why we need to solve it? You can see here some big guy, which we try to avoid in any cost, because when you when you produce a lot of small granules, they can come together and build this big granule, which can be dangerous for industrial process and also affect quality as well. So we try to control the granulation process and prevent caking of our granules. So to do this, we develop and deploy some automatic digital optical analysis directly into workshop conditions. So yeah, that's the place. So basically, it's a typical view of mineral filterizer plant. And here we implement our devices directly above the conveyor belt and tune them to control the size of granules, and that's how we implement the control of the whole granulation process as well. So here you can see some property of the process. So it's a real big flow with 50 ton per hour. Sometimes conveyor belts tend to be jumping, but not so. Uh, it's a rare case. And yeah, we have a big velocity here, like 1 or 2 meters per second. And yeah, we need to implement an online control 24 hours per 7 days. So this is the overview of the problem. So we need to decrease we need to increase the quality and decrease the counterfeit product, and that's why we develop and implement our dot pulse devices, because we don't like to build a new laboratory with 30 people of employees. And yeah, we build it to work in automatic mode, even in robotic condition, in robotic mode, like getting data analyzed and doing something then. But yeah, this is how we try to solve uh, a real industrial problem. So let's switch to the machine learning pipeline and what we understand to be science. So how we create it, and then we will see how we implement it directly into industry. So here in a bird view of our of all of our technologies. Sorry for there are a lot of pictures here, but basically it's a three stages, three um, clusters with different technologies. So first of all, our edge devices, which we name dot pools, and this device have an API service to share the data between different industries, between different departments into facility, as well as SQLite database and Python program with simple user interfaces. Next, we have our workstation where we write our codes, create our reports, and analyze an industrial tests. And yeah, our GPU server, based on Linux system, Ubuntu server, to be precise. And we have a single Nginx reverse proxy with a lot of implemented services. And all of this technology are connected behind VPN, as well as with ClearML system for logging our machine learning experiments. So this pipeline allows us to automatically develop and implement our different solution and perform a lot of really good experiments in develop our neural networks and deploy it with Ansible as well. So yeah, it's all about data really. So before you develop some MVP product or before you even have some ideas, you need to understand what type of data you have and how you can analyze and process this data fast and reliable. So that's why we implement our CVAT solution on our GPU server. And yeah, we have this sort of images. So there are images of granules directly in conveyor belt. So we implement our device, turn light on, get the picture, and then manually mark up these pictures to build our neural network solution. And yeah, try to mark up in big, so in big image, and then switch to train in a small tile size. It depends really of your needed of your task, but yeah, we have like 460 pixels for training, and we have a good result with it. So first of all, try to implement also an automatic markup system like SAM models, and when you have enough data, implement your own model into CVAT system. It's really helpful to automate this pipeline and develop a good data set for your product. And yeah, try to diverse your data, but be inside one visual cluster, because for example, if we use here a black granules as well, so basically speaking, mineral filterizer can be in different colors, can be black, can be yellow, can be white, but if we analyze bright images, so white granules or yellow granules, so in bright colors, not black, then it's okay. We can create one data set for it. But if you need to, for example, analyze black granules, then you need to develop a different data set for this task, because you can't develop a big model. You need to implement this model directly in a workshop condition. You need to analyze data fast. So yeah, use a different clusters. Here is an example of neural network implementation directly in CVAT system. So basically, it's a nuclear um, platform inside CVAT, and you can pack any of your models there. Basically, you need to use free files. So first two main Py and function YAML is template files where you describe your models, and this file related to the inference type, like ONNX format, OpenVINO, or other models, and the model handler where you implement the whole pipeline uh, to build the masks, to build the results for CVAT, to basically automatically mark up your data. So yeah, let's move forward. And finally, when you develop your data set, when you set up your machine learning systems, then just go to the experiments, make a lot of experiments, and please logging them, because uh, we really spoke a lot about GitLab or Git systems, but when you start doing your 1,000 experiments, sometimes you just forget to commit first, then train later, and to avoid this. To avoid these problems, we use ClearML server for logging as a logging system, because ClearML have a good feature. He he start automatically commit your changes even if you did not commit it before in GitLab or GitHub system. So it's really good because when you open your ClearML log for the one experiment, then you can see even uncommitted changes here. So it's really good to understand what's going on, how these experiments is different from the others. And yeah, please make a visual whenever it's possible, because here I show you how we visualize our batch for each 5 epochs, and then you can understand what's going on under hood of your model. So you can see how augmentation working, how the mask is prepared, and is it good or bad, maybe you need some tuning. So that's how we can implement an instance segmentation models based off semantic segmentation and even apply this model to the CPU units. So basically speaking, our devices are back to the industry, to the workshop. There are CPU devices without GPU, any GPU, but we can implement instance segmentation models there, and analyze each granules separately. Because we train our model, we see that we can train it to separate each granules. And when we get our single binary mask, then we use a classical OpenCV algorithm to separate these granules and analyze them one by one. So it's really good. And here's a pipeline when we move from science to industry. So first we try to create our pipeline in, Jupyter. Everybody hates Jupyter, but it's really good for make science, to build airports, to analyze what's going on, to test your pipeline for the models, to make your own loss function, to, prevent these granules to merge one with each other, and to implement your metrics as well. So when you're ready with your model pipeline, then you use ClearML and history file to make a lot of experiments, and that's how you move from pure science to an industrial approach. And doing this a lot of experiments, finally you can see a good model. And yeah, you need to see a good model. So please use a visualization, sorry, whenever possible, directly in ClearML. So it's possible to implement this visualization directly in ClearML system and see how you model training. And that's allow you to understand what's going on and select the best model based not only of technical metrics, but also with a visual impact. So you can clearly give this solution to any non-technical specialist, and they can see that your model is going well, doing well, and doing good stuff. So yeah, after that, select a good one, implement it in GitLab CI/CD system, use a test to see if it's suitable to implement on CPU devices, and yeah, next implement your model with Ansible to any device you need. So let's look how we do it directly in industrial condition and directly in workshops. So here a small pipeline how we implement our models to any our edge devices. So we basically use 2 solutions. First, the good one, the big one, when we use GitLab CI/CD system to perform a lot of tests, to use environment variables to upload this tested model in DVC to any devices. And yeah, we have also a reserve option to directly upload our solution with Ansible to any devices as well behind the VPN server. And yeah, when we perform all the science stuff and perform a lot of experiments and build this hacking hacking solution to implement, instance segmentation based on binary mask, single binary mask. We can achieve 39 FPS on CPU unit. So basically, we don't need a GPU unit for real-time calculation. We just can use a CPU unit and make it purely automatical, purely time efficient. And yeah, let's move forward. So here our pipeline, how we implement our device to any industrial condition. You need to talk with a technical specialist directly in the industrial facility to select a place when you need to implement your device. So it can be a conveyor belt or maybe a closed pipe or whenever they want. You just need to build some rails or system to put your device there, or maybe just screw it to any surfaces. Yeah. Sorry for the language. Okay, next we just put our device there, connect Ethernet and power to it, and turn on, and then magic start working. We implement an API system directly in our CPU devices, and use this. You can use this API system to call any data inside database and see a time trend with data. So, and yeah, please, when you perform any tests, just don't forget about hardware, because if you forget, yeah, it starts looking like that. And we need to make a cleanup, to make a strict procedure to the facility employees when they need to clean your device, when you need to make a checkup, for our industrial condition. We need each one checkup each 6 months. And we need some visual control, because even if everything is looking good, sometimes one per month or maybe per year, there can be so much dust that your device just turn off, and then you need to clean up. And yes, that's another reason that we use CPU devices, not the GPU, because the CPU devices can work again even after that sort of dustness. And yeah, let me show you some results which we can achieve during our work. So first of all, this small demonstration how we really control the granulation process. So this is our tiles with granules, so it's directly on the conveyor belt, flowing with 1 meter per second. Then we take an image using a fast camera and separate each granules based on single binary mask. So it's like instance segmentation based on semantic segmentation mask. And yeah, we can plot each 5 minutes for one dots per each fraction. So this based on technology documents or standards. They control different fractions here, so like 1 per 4 millimeter or 2 per 4 millimeter. And we even can base some, features, some typical features to control this process. So when you start to see some of these features, like in a market or like in financial area. So if you see these features, you now can understand what's the real average size of granules you have into this big flow. So you don't need to get one samples per hour, how it's doing in manual mode. You just think in an online condition, in an online mode, how your granulation is going, and you can understand what's the average size of granule you have right here, right now. And yeah, the workshop guys were very happy about it. And yeah, you need to also calculate a deviation between standard procedure, standard quality control. So we ask technical guys from facility give us an laboratory analysis each 4 hours. This is a standard procedure, and we evaluate them with our trend line. So here you can see two fractions. This is a from 2 to 4 millimeter, and this from 1 to 4 millimeter. And these dots are laboratory control. And you can see that the trend line and somehow are similar, because when they perform a manual control, they don't use a strict timing. So they must do it like in once per 4 hour, but plus minus 30 minutes. It's they not calculated, it's not give into account. So yeah, here we implement our third line, and the first thing that technical guys from facility tell me that no, it can be possible. We our process have a 5% deviation between our analysis, so it's not possible. And then we have a really good guys here. We discuss this problem and say, let's put some people there and perform the analysis each 5 minutes, and we will see. When they do it manually each 5 minutes, they see that they really have a 10% deviation between granule size, and that's how they start to believe us, to believe in our solution. And yeah, after that we have our first sold there. So, and now whenever we talk about a new technology, the new solutions, a new application for quality control, that guys say, yeah, okay, let's do it, because yeah, you open our eyes with your trend line. When we see our standards files and laboratory procedure, we don't see how many deviation we have. But with this solution, they can see a real deviation between the analysis, and that's how they can control the process better. So not only with overall look of the trend line, but also with deviations inside. So that's a real surprise, but we can implement it as well. So yeah, of course, another tricky part is to analyze outlet data. So you can see here, maybe, yeah, something like that. So it's like an outlet here, and we need to understand why it's happening. And sometimes when we look into our images, we can see a big part of granules here. So yeah, it's a good part too, because you can not only analyze the shape of trend line or the granulation itself, but also the outlets or some anomalies. And this is a valid information for the technical guys as well. And yeah, here overview of the results. So what I want to highlight here is that you need to not only to do science or R&D solution, not only train your models, but you need to speak with industry in one language. Like you need to see on the technical guys there. So the technology masters and workshop managers is your guys, is your target auditor, not the IT department, because whenever they want to implement your solution and buy your devices, the first guys to ask will be a technology masters and workshop managers, and you need to build the solution for them, and prove your validate your solution for them in their own languages, using their own standard procedures, and evaluate your results with the standard quality control techniques. And yeah, please use the Ansible whenever you can, because it's a great solution to implement your machine learning pipelines in any devices, in any condition. You can do it. When we perform an industrial test, we just connect some phones with mobile internet and use SSH to monitoring our devices, because that's the best and easiest way to see what's going on, to fulfill our data sets, and retrain our models if needed. Yeah, please separate a configuration file for your devices, for your user interfaces as well, because SSH-X is too slow. So when you have a big workshop with a big machines there are a lot of noises, and they have very bad internet. So you need to turn a text file, and that's how you modify your programming solution, not with user interface. And yeah, single API service and CI/CD procedure are great helpers as well. So also we have some limitations right now, but maybe it's not so big limitations because we don't really have access to the production line. When we perform an industrial test, we have some access. We can negotiate it with the technology masters tete-a-tete to give us some SSH access to the devices. But when you implement it in the like a solid solution there, they cut any internal access to the device. So it's no needed to use a Grafana to monitor NQ metrics because your possibility is, 1 per 6 months to move directly behind your device, connect directly with the Ethernet cable to your notebook and upload any data. And for any other time, you don't have any access to your devices. And yeah, right now we try to implement, a single backend for each our devices to maybe communicate with them to collect all data in one places, and for that purpose we start using PostgreSQL databases with S3 Minio solution as well. So yeah, basically that's all. If you have any questions here, please ask me in any language, in Russian and English, and I try my best to answer it.
Вот вы получаете информацию об объектах, которые отличаются от гранул, то есть о больших объектах.
Да.
Анализируете ли вы помимо изображений какую-то информацию от устройств, которые эти объекты формируют? Мне кажется, это был бы неплохой тейк для бизнеса, анализировать ошибку устройства, которое формирует такой объект.
Да, это глобальная идея, и мы под это дело подводим большой проект как раз с предприятием, с которым мы работаем, для комплексного анализа производственных процессов. Потому что сейчас они на производстве имеют только базовые контролирующие устройства, это токовые нагрузки, это иногда напряжение в сети, скорость, редко когда масса даже производимой продукции. Поэтому мы хотим обвязать их таким оптическим контролем по грануляции, по массе продукта, по забивке сит, например, и связать все это в единую систему вот для анализа того, как вообще происходит производственный процесс, насколько эффективно он управляется. Потому что вы абсолютно правы, нужно контролировать не только процесс грануляции, но и все связанные процессы. Насколько эффективно работают сета, насколько эффективно работают дробилки, как вообще у нас происходит производственный процесс. Это, безусловно, следующий шаг. Вот после внедрения, почему я упомянул, что наши устройства, они роботизированные, что они могут теоретически у нас есть встроенные PLK-контроллеры, которые позволяют управлять, например, шиберами, переключать потоки и так далее. Это как задел на будущее, да. Но в данном конкретном кейсе вот основной стек это на MLOps, который мы использовали. Спасибо. Я буду рад пообщаться со всеми после доклада.
Я бы пообщался с вами еще после.
В белой рубашке, в джинсах, дырявый кроссовок, так что не пропустите.